Share. Share. Hide. Good.
Oh, yeah.
My husband and I were just sitting on it. And we just came home and
I get that point. It's gonna sit down. Who can stay here the longest? They get fed up. They go to the house and or maybe they have a conflict. Who can build their best stuff around their house?
just like looking at those,
So you got people with sandbags, they use walls.
like I can see there's studies here and there, but just the sheer amount is just like now. Like man, I'm too hungry to go over that.
Crazy.
Is that like a common occurrence up there? No. Really? Yeah. Okay. Right. What?
All right, who's ready? Sweet. So, if you guys recall, we have an exam this Friday. So it's going to be the same as last time. So questions that you guys have entered after each class will be online. You'll have 24 hours from normal class period till 24 hours later to do it. It seems that you really like the multiple attempts option, so I'll leave that selected. So if you don't get 100, it is no one's fault but your own. So we're gonna quickly go through story mapping and intro to like the web and the architecture of the web today. So starting with the story map. Yep.
When will we hear back on like your feedback on the?
Good about the projects, yeah. So by Wednesday, I'll go through and have some notes on everybody's projects. Some of you guys made me an owner of your project, and I can type them directly in there. Others did not, so I'll have to send those to those guys separately. But I'll let you know what I think about your proposed project. If it's doable, if it's too easy, and if you were successful, what kind of grade it would be landing you. So that'll be by Wednesday, because hopefully everyone submitted the link to their repository, so I should be able to find everyone's pretty easily, all that kind of stuff. So about story maps, you guys have done a little story mapping so far. It's pretty easy. Hopefully you have seen. Do you agree or not agree with that? Yes. So it's basically, you have to have some data in ArcGIS Online, and whatever data you have in ArcGIS Online, you can make a story map out of. So the main thing you're going to have to do is pick a template that you want to follow, right? There's only a certain amount of templates that are available. Oops, new tab. New tab. Right, and you can pick basically what the layout is. So do you want it with one picture and people swipe to the right to move through your story map, or is it going to be more like a top to bottom type thing? Some work better for certain things. How do you know which was good for what? Look at the examples. If you find one that you like, which is related to your project in some way, or you think tells a story that is similar to your project, just use that one. So if for whatever reason things you want don't exist, that's when you start building widgets, right? So if you wanted a story map that had additional stuff in it that wasn't like an embedded web page of your own, which could contain a chart, a graph, images, anything like that, then you can extend the existing templates by making your own through the installable web app builder and like all the widgety type stuff that we saw. All right, so it's pretty easy to make. This is supposed to say beautify your page, not beastify or beatify. All right, so whatever you think is helping you tell the right story is what you should be adding. So if it's a story about data, you should have tables, charts, graphs. If it's a story about where wildlife lives, having pictures of the wildlife might make a little bit of sense. So luckily with most stuff Esri, as long as you're like in the Esri world, it works together pretty easily. All right, so your assignment either was or is, did you guys already have to do a 3D story map for your lab? Yes. So your assignment was take some of the 3D layers that we have for campus, bring them into a story map. So that was find layer, add to map, or create map inside of your account, create story map, link to that data. So in the Esri universe, it's pretty simple to do as long as the data are up inside of ArcGIS Online. So it's one of the main benefits of using or paying Esri to use Esri and having an enterprise agreement so you get a organization, is that all the little pieces that they make work together pretty well. Can't do everything that you want, but it will do most stuff that most people need. So you guys have any questions about story maps? It's pretty simple. Did anybody make anything cool? No. Did the minimum amount possible in order to complete the tasks. Good job. Did anybody use the LiDAR for anything? I heard someone say something. So you had the buildings and the terrain. Who used buildings? Who used terrain? Because you were worried? So something interesting I learned at the Esri Developer Conference, you might be worried about having points, lines, and polygons that don't have an elevation associated with them. Right, so where's it going to show? If we have the terrain of campus and you add a point or line or polygon like a sidewalk or a road or a building footprint, like is it going to show like up in the air or is it going to be below ground? Any guesses? It actually shows up at ground level. So as soon as you add a 3D layer, like the terrain layer, all the other points, lines, and polygons that you put on top of it just automatically follow it, which is pretty interesting or pretty cool because I thought it was going to take a lot of like work to like link them together and like associate the Z coordinates from one layer onto another one. Apparently, just like projection magic, this works as well. So Esri is good for something. Many things. Cool. All right, so who thinks they're going to be doing a story map for their project? Are you guys all on the same teams? No? Maybe? Yes? It's pretty easy, and it's very, I'll say newsy, but like it's good for doing news press releases about something, because if you can link to that, like interactive content where people can like step through stuff and tell a story, is really good for marketing material. So our College of Geosciences now wants us, when we like write news stories for them to push out, to also make a story map about it, because then you have sort of rich media content that people might actually look at rather than just text of geography professor was up to this thing this last week. So when you get jobs at companies, you might think about like when they need marketing material, using this as a way to market the company or market your business that you start or whatever. Cool. So story maps, follow instructions, they work for the most part, as long as you don't want to do anything outside of the box. All right, so next up, is a very brief introduction to web servers and how the internet works, starting mostly with an image. All right, so let me zoom in so you can see this a little better. This is an Esri image of how they imagine that sort of the web architecture is going to work. So in architecting, meaning how are you going to put all the pieces that you need together in the internet world, it's generally a good idea to separate your things into pieces. So at the top, we have the client, which could be mobile devices, web pages, tablets, any way that people are going to be working with or interacting with your system. So in the future, it might be like holograms, whatever. So there's going to be like some end user client that's going to be using your data in your system. It's going to be transmitting requests for websites or images or point signs and polygons over the internet using HTTP, right? So using hypertext transfer protocol to a web server. So the web server is something that just sits there on generally servers that are always on, always connected to the internet, always have a static IP assigned to them, and always have a static DNS name. So that way it's always available and where it is always known. So the client transmits a GET request to go get data or get a page to the web server, which is just sitting there listening. And then you have the web server sending that to the application layer, which would be the GIS servers, right? So web server understands HTTP, so it understands like web browsers asking for stuff and mobile phones asking for stuff. It does not understand geography in any way. So it's just listening there for requests coming in that are for something and then returns them back to the user. So since it doesn't know anything about geography or GIS, we have another layer called the application layer, which is the thing that actually does the work of the application. So these would be Arc Server or ArcGIS Enterprise or ArcGIS Portal, or if you want to use open source, it would be GeoServer. So these are the ones that understand geography and coordinates and are specifically designed to serve up vector data, point signs, polygons, or raster data, which would be the small tiles of images. And then all the way in the bottom, we actually have where the data lives inside of some kind of database. So that could be Microsoft SQL Server is a very common one, could be Oracle, could be Postgres or MySQL. Postgres and MySQL are both free and open source and are used a lot because they're just as good for the most part as Microsoft SQL Server, which is not free, and Oracle, which is even notter freer. So you see we have a couple different levels here. All right, so when you're designing or architecting your system, you'll have some group of people working on the front end, the client side, so this would be an HTML and JavaScript. You would have a web server, which is hosting the website. Then you have some GIS servers, which actually understand geography. And then you have where the data live. And the reason that we break it up into these different components is that you can scale each of them independently of the other, right? So if you start off with AggieMap getting 1,000 users a week, things are going great. Then it's the first week of school and you get 55,000 users an hour and it starts slowing down. Then you might want to increase the resources of either your web server, your GIS server, or your data server, right? Depending on the type of data that you're storing, it might be best to have a lot of different data servers. So when you see poor performance, you have to start looking through each of these pieces to see which one is pinned, meaning all its memory is used or all its disk is used or all the CPUs are used, right? It could be at any one of these levels, right? It could be the web server is configured wrong and it's not accepting enough requests. Or it could be the GIS servers, the Arc server is overloaded, so you need to add more memory or add more Arc servers. Or it could be that the database server is too small, doesn't have enough memory or disk space, so you want to add more of these, right? So separating it into these various tiers allows you to scale each of them as you need to. So this is a general architecture for everything on the internet, right? It's not just GIS. For Facebook, there's a mobile app and there's a desktop app. There's more than one web server, I guarantee you. There's their little application layer of everything that they have built for managing actual Facebook, and then it lives in some database somewhere. Right, so no matter what kind of web thing you are working on, you're going to have this level, just like this. So now you're thinking, Michelle, shit. So I got to maintain 1, 2, 3 servers times however many need to be managed all at the same time. Yes, you do. But luckily, all 3 of these layers, web servers, GIS servers, and database servers, are built nowadays to scale, right? So for database servers, you can make what's called a cluster. So you have, instead of just one, you have one and then a bunch of other ones as well. So the main one acts as the primary server, and then as it becomes overloaded, it starts pushing data requests to all the other servers. For GIS servers, you can have multiple of those as well. So for campus, we actually have 3. So GIS dash, oh, it's not coming up on there, but I will have it here. Tab gis-1.ops.tamu.edu. All right, so I'll bring that one up over here. Whoops. Slash rest/services. So it is GIS-1 dot operations dot tamu.edu slash arcgis slash rest slash services. Right, so when you get data from AggieMap, it's getting it from gis.tamu.edu. Right, so if we open up AggieMap, then we right-click, inspect, view network traffic, close this annoying thing, hit F5, right-click, inspect element, network, F5. You can see that the actual requests, open a new tab, are coming from gis.tamu.edu. Open in new tab. But gis.tamu.edu is actually what's called a load balancer. So there's 3 ArcGIS servers behind it, and they are named gis-1.operations.tamu.edu, gis-2, and gis-3. So there's 3 instances of the actual GIS server, and the front of it, the web server piece, just round robins requests coming in. So when it gets a new request, it sends it to GIS-1. When it gets next request, it sends it to GIS-2. When it gets the next request, it sends it to GIS-3. That decision was made because at the time when they were setting it up, Arc Server was the problem. So everything else was working fine, but Arc Server was too slow. So if that occurs, then you can set up more than one of those Arc servers to handle requests. Right? So it would, if you have 3 of them, it cuts the load on any one of them in a third. So each of the servers which was not performing well is now only getting 1/3 of the traffic. So hopefully by doing that, it increases the overall throughput of the whole system. So throughput is how many web requests can it handle at any one time. So now the problem they're running into is that there's not enough memory on each of the GIS servers. So while we were at the Esri Development Conference, we sat down with the wizard of Arc Server performance problem analysis, and we logged into the GIS servers and did all kinds of fancy tricks beyond just regular Task Manager. So Task Manager is this guy. If you don't remember, Task Manager, it will show you, how much of your CPU is being used by which of the different types of processes. So through more complicated ways than I have ever seen anyone do before, the guy was able to figure out that the reason that AggieMap is sucking is because none of the ARC servers have enough memory in them. So when you don't have enough memory, what would be in memory gets written to disk because there's not enough room in memory to store it. So then when it needs it, it has to go read it from the disk again. So it does what's called thrashing, which is from memory to disk to memory, memory to disk to memory. So he said that if we doubled the memory in the machines, we would definitely get double the performance. All right, so fortunately or unfortunately, it takes that type of analysis to figure out which piece is messing up your system, because it could be anywhere in here. If you do a bad job programming the JavaScript for the client, they're going to have a bad experience. If your web server can't handle the amount of requests coming in, they're going to have a bad experience. If your GIS servers are overloaded and can't produce the data to show the map, you're just going to have a bad experience. If your data server is not powerful enough to give the data to the GIS server, you're just going to have a bad experience. So this web architecture may look complicated that it's got these pieces, but it's actually extremely helpful because you can sometimes quickly, but hopefully always figure out what is the actual problem. Is it data related, is it Arc server related, or is it web server related? So the rest is just simple. What is what? So the client, as mentioned, is anything that's contacting your stuff. Could be web browser on a phone, could be web browser on a tablet, could be web browser on an actual desktop, or it could be the application that you wrote for a cell phone. So if any of you guys start writing your own cell phone apps for iOS and Android, they're writing the client that's going to have to send HTTP requests to the web server, get the data back, and do something with it. The web server generally comes in two flavors. There's the Windows one and the not Windows one. So the Windows one is called IIS, Internet Information Services, and it's on every single Windows computer. So if you open up your computer and type IIS, you either see something or nothing. So if you see nothing, it just means that the checkbox to turn on the web server has not been checked. That's by default the case, because otherwise every computer on the planet would be a web server responding to web requests. So you just have to go into the Windows setting and click the thing that says turn on IIS, and you now have a web server, just like every website you've ever been on the internet. So that's the IIS version. The non-IIS version is Apache. So there's the Windows way of doing web programming and the non-Windows way. The non-Windows way is known as AMP, Apache, MySQL, and PHP. So Apache would be the web server, MySQL would be the database, and PHP would be the programming language. So they're equally common. Just depends on what was there when they started doing all of this stuff. So in my group, we do the IIS version because I know Windows really, really well. But it's sometimes a hassle to have to deal with all of Windows when all you want to do is serve up web pages. So a lot of people use AMP instead of Apache, MySQL, and PHP because that is also 100% free. Apache is free, MySQL is free, and PHP is free. So you're going to have a web server out there, a client, a GIS server of some kind, and in the Esri world, that's called Arc Server, something you may have heard of. It has now been rebranded as ArcGIS Enterprise, but it's still Arc Server. So this is the thing that understands geography. It understands that the screen is this big, here's top left coordinate, here's bottom right coordinate, go get the tiles from the server that are filling that screen. The web server doesn't understand anything about geography. The application layer server, in this case the GIS server, is what knows about geography and how to process geographic information. The database server is what stores your data. There's lots of different database options out there. The three most popular ones would be the most popular free one is MySQL. Second most popular free one is Postgres. Of the non-free ones, Microsoft SQL Server is more popular than Oracle. Have you guys heard of Oracle? Probably. Do you have any idea what they did prior to this lecture? So they were primarily a database company. So Oracle database is the most expensive database that money can buy, but it's also really, really powerful and high performing. They now are also the owners of Java. So if you have Java on your computer and it's saying Java needs to update, Java needs to update, Java needs to update every time you turn it on, it's going to bring you to an Oracle page to download the Java update. Postgres and MySQL are both free. MySQL is more popular. I think they're probably equally popular, but I've used MySQL more than Postgres. All of the different types of databases support spatial data. So you can load points, lines, and polygons into them directly as geometry and geography objects. So actually, you might have heard of something called ArcSDE, Spatial Database Engine. No, never seen it in job ads. So back in the day, before databases could store geographic data, Esri built the ability to do so on top of all of the other different types of databases out there. So before MySQL and Postgres and SQL Server could store spatial data, if you wanted to store spatial data in there, you would use Esri's SDE Spatial Data Engine, which adds a layer on top of your database that understands geography. These days, you don't need that anymore unless you want to do versioning. So you can store points, lines, and polygon data directly into SQL Server, MySQL, Postgres, and Oracle. So inside of ArcMap, when there's like all the way at in our catalog, it's like add database connection. You may have never clicked on that before, but you can point it to any database and just load spatial data into it. And you can cut, paste from your shapefile on your computer over to the server, and then you can pull from the server instead of your own shapefile. So I mentioned a little bit about versioning. So what does SDE actually provide? It's very similar to GitHub in that you can track changes that people have made, and you can check out and check in files. So that means you can have multiple people working on the same thing and handle the merges in the data. Very, very similarly as you're doing it in GitHub. All right, so that is the basics of the interwebs. So, did any of you know this in advance? There you go, you're learning something in this class. So when you go work at a company, this is what their stack is going to look like. They're going to have web pages, mobile apps. They're going to have some kind of web server. If it's a small company, it's going to be Apache because Microsoft licenses are not cheap. They're going to have some kind of geographic data server, right? If you work for a big company, it's going to be Esri because they have money. If you're working for a small company, it's going to be GeoServer because it's also free. And then at that company, they're going to have some kind of databases for storing the actual data. If it's a small company, it might be MySQL. So this is all of I had one whole undergrad course just in this, in the computer science department. So this is the entirety of one semester of computer science something or other at Rutgers in 50 minutes. So the hardest part of this is tracking down the culprit, right? So ArcMap has sucked, or sorry, AggieMap has sucked all semester. Can you guys agree? Almost every time I try to bring it up in class, it does not work. The first time, did it work this time? It did, surprisingly. Good. So the way you start analyzing this stuff is, did I close? No, there we go. Is you start at the end. So you open up a browser and you see what kind of responses are coming back. Is it finding the page and it's just taking a long time, or is it getting a 404 page cannot be found error, or is it a 500 error, meaning that something is wrong with the web server? So you look at the HTTP codes that come back, and then you start working your way further and further down. So if it's responding but not working right, then you skip the web server and you go to the GIS server. It's not responding, then something is wrong with the web server, and you try working with that. And then you look at the resources under normal load, so under normal traffic coming to the GIS servers, and see if they are maxed out on memory, maxed out on disk speed going around, or maxed out on disk usage. Right? If those are fine and are working great and you can query them by themselves, then it's something wrong with your database. Then you start doing the exact same stuff on the database. You check the size of your tables, you check the index usage on your tables, you check the statistics on all the different tables to try to figure out what the slow piece is that's slowing it down. And then, once you identify what the slow piece is, you add more resources to whatever that slow piece is. So if it's like AggieMap, the GIS servers were under too much strain because when they were rented as VMs, they only had 8 gigabytes of memory, which for a server is ridiculously low. Like everyone's laptop in the room has more than that right now. So when the memory is overused on a Windows computer, bad things happen, and those bad things were happening, so then they added more of the exact same structure, so more with 8 gigabytes made it better, but still having a problem. Right, so then we went and we investigated, and we see that memory usage is still out of control on all of these. So we got to add more memory to each of them. They were showing us some super interesting tricks as well, because on an Arc server, inside of each of these layers, right? So if we look at F-core, services, F-core, each of the different maps that it's publishing and making available are different services. And there's pretty complex settings that you can do inside of Arc Server to say how many threads or how many instances of each of those services you would like to be running. So if it's a very popular service, you might spin up more instances of it. They usually go from 0 to 5. So 0 means don't turn it on until somebody requests it. 5 means have 5 copies of it running at all times, ready to listen for stuff. But as you make all of those copies, the size of these gets multiplied. All right, so there's only so much memory on a computer, 8 gigabytes, 16 gigabytes, 32 gigabytes, something like that. And each one of these map services is a size. So as you start multiplying, we need 3 versions of the latest base map. You now have 3 copies of however big it was. So there's a significant amount of tuning that you can do once you figure out who the culprit is to fix the problems that it's having on the rest of your Arc server. So turns out the main person messing up AggieMap is actually not anything to do with AggieMap, it's the transportation maps. So it's unclear why all the transportation maps are so gigantic, but they're 5 times the size of any of the other maps. No one knows why yet. We haven't asked the transportation people. But because these are so big, and every time you're sitting at a bus stop and your map is refreshing with the locations of the bus as you're sitting there, it's making more and more calls to that service. So this gigantically large map, for no good reason that we can tell, is being, multiple copies of it are there, and it's using most of the memory on the whole server. So this gives you evidence to go to people on your team and say, why'd you make such a shitty map? Why is your map 5 times the size of the regular campus map? So this is just inside of the application layer, so inside of the GIS server, there's one map misconfigured that's messing up all of the other maps. So this doesn't have to do with the stack of web server to GIS server to database server. This is a misconfiguration of the application that's running. So you wouldn't know that until you get into the nuts and bolts of Task Manager and other performance tracking stuff on the server to see, all right, this should be fine, why is it not fine? And then you can figure out who the person doing all the damage is. So I have no idea what this map is, but it's gigantic and takes up a lot of the processing. So you can see it's still loading. So this one often takes 60 seconds to load. and it's used all the time. It is different sizes of annotations of parking lots, is what I can see. And then construction shapes and parking and different colored stuff. So I don't know what this is used for, but it is causing a lot of problems. So the response time should be under a second. So inside of Arc Server, you can also track the average response time of a layer, so of a map service. And this one is routinely above 60 seconds. So something is fucked with it, and it needs to be fixed somehow. So, fortunately or unfortunately, oops, that's not the right thing. This is the architecture. This is how every single website is made that exists on the internet. When you jump into a company that's running a website or running GIS applications online, it's going to look exactly like this. And your job may be figure out why it's so slow. And there's a bunch of tools that you can use, and someone's just got to show them to you the first time, and then you'll know how to use it. And it gives you ammunition to either like add more memory to your existing virtual machines that you've rented, or buy actual physical hardware to do it instead, or to tell the people on your team who are doing weird things, stop doing weird things because you are killing the rest of all of our web traffic. All right, so on Wednesday, we will be talking more about web servers in greater detail, and we will be reviewing for the exam on Friday. So remember, you can come to class on Friday if you wish to take your exam in here, or you can take it in your pajamas at home, whatever you like. And hopefully nobody went to lab. Oh, this is the old one that's still not due, right? Yeah. There is no lab this week.
Story mappings do this.
Oh yeah, but you had 2 weeks. That's what I mean. Yeah, sorry.
Definitely have lab this morning.
Okay, you had lab today then. There is lab this week. No lab next week. Yeah. So next semester there will always be lab. Because there's like the exams are not so hard in this class that you can't also do a lab that week. And we can get a lot more accomplished if we had labs. And then starting, so next week will be databases, which is basically we set up a database and you guys are going to pull data from it, do stuff. And you will have your own virtual machine that you will make into a web server and a database server, eventually ArcGIS Enterprise and Portal server. And then TBD, what's happening after that? Cool. So, hope everybody had a good break. Welcome back. What's up?
So we're trying to get our server made for our project. So we synced out Hank to see how he constructed his server for the last semester's project. And he said that